So in this example, we are going to use the cosine law again because we end up having a side, angle, and side given to us. So there's our side, angle, and side. Okay, so we have the side, angle, side. So in this case, cosine law would be appropriate. So again, with using cosine law, I want to find that unknown side C. So I'm going to make sure that the angle on the other side of that equation, so this angle over here, okay, we need to make sure that that matches the opposite side C. Okay, so that's the constraints that we need to make sure we follow for cosine law. So as I plug this in, I get C squared is equal to 14 squared plus 22 squared minus 2 times 14 times 22 cosine of 78, and I'm getting a value of 551.93. I'm going to square root that to get side C, and for side C we get 23.49. Okay, so that's the length of side C. So I'll just make sure I label that 23.49. Okay, so I still need to solve for the other angles. Now, in this case, I'm going to use the sine law to solve for the other angles. Now, we do have to be a little bit careful with sine law because we do have to worry about an ambiguous case when we use sine law. But in this case here, it looks like based on the sides of this triangle, and when we solve for theta 2 will not make sense in this problem. So I'm going to go ahead and use the sine law. So sine A over the side length 14, so I'm just going to maybe draw a line here, is equal to sine of 78 degrees over the side length we just solved for, 23.49. Okay, so then I end up with sine A is equal to 14 times sine of 78 all over 23.49. Okay, so typing that all into my calculator, I'm going to end up with 14 sine 78 divided by 23.49. Okay, that gives me a sine ratio. So sine A ratio works out to be 0.583, and then angle A is, when I arc sine that, okay, so I end up with 35. Angle A works out to be 35.66. So that's going to be 35.66 degrees. And then solving for angle B, we're just going to subtract from 180. We are going to end up with 66.4 degrees. It looks like, well, it should be, just going to fix that. Looks like my rounding's a little bit off. Should be 66.34 degrees. Okay, so then I have all the sides and angles, so I've solved for that triangle. Now, just a note here, that original angle here that I solved for is using the sine law, so I have to do theta 1, but the reason why I don't have to worry about the theta 2 is because when I actually calculate theta 2, so 180 minus 35.66, I end up with 144.34, and that's actually not possible because I can't have this angle in here equal to 100, what does it say, 144.34, because with the angle that was already stated, it doesn't add up. So we can actually eliminate that possibility when we solve for the theta 1. So, but we do have to be a little bit careful if we want to avoid having to deal with the ambiguous case, we really should use the cosine law like I did in the previous example. In this case here, because of the shape of this triangle, we are pretty safe in using the sine law.